Hi, my name is Mike Nalls. I'm here to present on NIH's CARD and how that relates to hybrid cloud computing. We're really focused on managing massive global data sets that are distributed across the world and building communities that facilitate collaborations as well as fill gaps in the large global Alzheimer's disease and neurodegenerative disease research portfolio, complementary to things that are already being worked on. So just to give you an overview of the things we work on, our focus is CARD, which is the Center for Alzheimer's and Related Dementias under Director Andy Singleton. It's really about accelerating the AD and ADRD research without reinventing it. We're really interested in connecting data silos and harmonizing data across silos and involving the IRP and ERP. Most of our work focuses on collaboration, as is evident in kind of a secondary project we do a lot of work for, which is the Global Parkinson's Genetics Program. And this is a great collaboration with the Michael J. Fox Foundation in particular, and it's 150,000 genotypes and deeply clinical characterized Parkinson's cases from every continent except Antarctica. So there's a lot of issues working across all these data silos that we run into on a day-to-day basis the hybrid cloud can help with. Anything from costing tons of money to download massive data sets, to not being able to replicate studies because there's no code available, to not being able just to find the data. Or, one thing that's tough when you're at NIH is working iteratively on collaborations with external collaborators, namely because they can't get inside the NIH firewall and use NIH compute resources. So kind of being able to switch between local NIH and the cloud is really, really helpful in that regard and really democratizes what we're doing at the IRP. So to address a lot of the issues that we're seeing in the previous slide is kind of combining the best aspects from commercial cloud providers such as GCP or Azure, and they're theoretically unlimited compute, which is great for burst jobs and doesn't have any upkeep, and also bringing together, private quote unquote clouds that are on premises and bare metal, and really trying to switch seamlessly between the two to maximize value. In practice, this is how our team works. So we really have production level code done locally and then pushed to shared data platforms that we participate in, such as Terra, the Int'l, and the Alzheimer's Disease Data Initiative. These are all cloud-based. And then working on centralized collaborative coding that mirrors both private and public repositories and accompanies any publications. These really help with collaborations. We've been also working with Tim Miller and the awesome folks at the NIH HPC to really streamline our movements of code and results between BioWolf and commercial clouds and things like that. We do use BioWolf a lot to complement the commercial cloud for large sustained use jobs, right? So we think about the cloud as kind of open collaboration, global bursting, and then BioWolf as internal kind of long-term sustained use jobs. And they all really work well together. In general, when we put things in the cloud, we put polished, clean data and clean code, whereas out of the cloud, we do a lot of work on development and things like that, and data munging. So at CARD, we really kind of try to function more as in the vein of a tech company than in a traditional research group at NIH, because we want to build products for the community. So this is just a snapshot of all of the cloud-based tools that we're building that also work quite well on local infrastructure as well. This includes like a large data lake that's really feeding data into these safe data sharing platforms, a platform to synthesize multi-omic data, a way to cluster and predict outcomes in neurodegenerative disease, our GenoML, which is our automated ML pipeline that we've used to democratize these complex workflows in genetics and biology, and then Cluster Buster, which is just something that we put together to let people outside of our team use cloud-based infrastructure to ascertain the quality of genotypes from large scale, almost population or biobank scale genotyping studies easily. And we also use the cloud for these really large scale efforts and data commons, such as CRISPR Brain, as an example where we need scalable infrastructure for many users. I think this has 6,000 users in the past 2 months, many repeat users as well. So we need to have this public-facing, scalable infrastructure that the cloud is really, really useful for. Now, we're really trying to use this hybrid cloud design to democratize data science and bring together people for compute and training and data access, as well as sharing code and ideas and building a community. One of my huge goals in particular is moving the concept of data collection site and really adding the concept of data partner. This is really important as we increase the diversity of the data sets and projects we work on, and really try and bring everybody on a global scale, democratizing resources across places that might not have the same, easy logistics as we have at NIH or other, really lucky places. We're also really interested in kind of supporting this through cloud computing credits, thanks to the Strides team, and really simplifying access to data sets, but keeping it safe. So we're really excited about connecting cloud silos, and all within the context of inclusivity and compliance, and GDPR is one of those big issues that we're working with. So having multiple localities for data centers is really important. So I just want to say thanks to everyone, and if you have any more questions or interest or potential collaborations, please feel free to email me. This is a huge amount of work from a lot of really talented people. So I wake up every morning thinking about how lucky I am to have this list of people on the left side of this slide able to inspire me every day. Thanks.